Hello everyone, welcome to solve this math Olympiad algebra problem, and here we have a to the power of m plus 2 to the power of m equals to 130, and we solve this problem for the values of m. So here the very first step we are going to do is here first we rewrite this equation as in this form. So we write this 8 as 2 cubed. We know that the prime factors of 8 are 2 cubed and its whole power m, plus we write this term as 2 to the power of m equals to 130. So here we use the nice property of exponential law, and we know about this exponential law. If we have a to the power of m to the power of n, so if we interchange these two exponents, it cannot be factored our final answer, and we write it as a to the power of n to the power of m. So here we need to interchange these two exponents, so that by according to this exponential law we interchange these two exponents, and it is written as in this form: 2 to the power of m and its whole cubed plus 2 to the power of m equals to 130. So next in the next step we take here 2 to the power of m is equals to y. Okay, so that when you take y equals to 2 to the power of m, and you see that 2 to the power of m be the exponential function, so it cannot be equals to 0, so or it cannot be negative. Okay, so it means that our y is always greater than 0, so we cannot choose the negative value of y. So that here when you substitute this value of y here, so above equation is written as in cubic form. It is y cubed plus y is equals to 130. So now we move 130 in the left hand side, and it is written as y cubed plus y minus 130 is equals to 0. So here you see that we rewrite this minus 130 as in this form: y cubed plus y minus 125 minus 25 equals to 0. So minus 125 minus 25 equals to minus 130. So now we rewrite this equation as in this form: y cubed plus y minus, this is 125, and we write it as 5 cubed, and we write this 25 as 5 square, and this whole equation equals to 0. So in the next step we make the pair of cubic terms with the cubic term and the square term with the other term. So we write it as sorry, here we have mistake. This is 130, so we write it as minus 125 minus 5. Okay, so this is our minus 5 only, so we write it as y cubed minus 5 cubed, and we combine this y with minus 5, and it is written as y minus 5, and this whole is equals to 0. So now we use here the nice cubic formula, and you know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. So here we need this nice formula in the first factor. So our first factor is written as in this form. This is y minus 5, because we have first factor is a minus b in this formula. So we have y minus 5 into y square plus y into 5 and plus b square. So b is 5 square, and here you have y minus 5. We write it here y minus 5, and this whole equation equals to 0. So now in the next step, here you see that from both of these terms we have y minus 5 be the common term, so that we take common y minus 5, and the remaining terms are y square plus 5y plus 25, and here we take common y minus 5 and we get plus 1 equals to 0. So here we need to simplify the terms, and we get y minus 5 into y square plus 5y plus 26 equals to 0. And now here we convert this into the two cases, so that our first case is we take y minus 5 equals to 0, and the second case is we take y square plus 5y plus 26 equals to 0. So from first case we easily get the value of y equals to 5, and now in order to find the other values, here we need to solve this quadratic equation. So here, but we need to simplify this one. We have y equals to 5, and now we back substitute the value of y here, and we know that the value of y is, we take in above steps are 2 to the power of m equals to 5. Okay, so in order to find the value of m, here we need to take the log on both of the sides, so that when we take this log, it is written as a log of 2 to the power of m is equals to log of 5. And now we use the nice property of log, and we move this exponent m in the front of this log, and it is written as m times of log 2 is equals to log of 5. So here we use the calculator or logarithmic table in order to find the value of this log 5. So the value of this log 5 is equals to 0.6990, and we know about the value of log 2, it is 0.30 and 10. And now here we move this 0.3010 to the right hand side, and it is written as m equals to 0.6990 divided by 0.30 and 10. So now when we divide 0.690 divided by 0.30 and 10, it is equals to 2.3221. Okay, so this is the approximate value of m which we get here from our first case. Okay, so now here we move towards our second case. So now this is our second case, and now first we check is the second case have some real roots or not. So here we use the discriminant formula in order to check the roots of this equation. So first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 5, and c equals to 26. And here we write the discriminant formula, and you know about this formula, it is delta equals to b square minus 4 times of ac. So this formula is denoted as the discriminant formula. So this formula gives us the behavior of roots, or behavior of the coefficients of the given equation, or behavior of the roots of the given equation. So now we substitute the values of a, b and c here. So b square is b is 5, and 5 square minus 4 times of a is 1, and c is 26. So we know that 5 square becomes here 25 minus 4 times of 26 is equals to 104. So now we subtract here 25 minus 104, so it is equals to minus 79. So here you see that the value of our delta is less than 0. So if the value of delta less than 0, it means that this quadratic equation does not have the real root. Okay, so here we rejected this case because this equation has no real roots. Okay, so finally we have the only one root of the given equation, and this root of the given equation is m equals to 2.322 So this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.